Okay, hello everyone. Welcome to the first webinar this year. My name is Adam Polak. I'm a head of Node.js at TSH, the software house, a software making company specializing in building custom web application using Node.js, PHP, and React. Last year, most of our webinars were about microservices, and this year we start with something very hot, serverless, especially AWS Lambda. Before we start, a few organization stuff. So feel free to ask any questions you want. You can use a specialized tab on your right called questions there. What's more, I also recommend you to use the special voting functionality. You can give a vote to a question that you find the most important for you, and we will probably prioritize those questions first and try to answer them as soon as possible. For the rest of the questions, do not worry. If we won't manage to answer all of them, we'll prepare some article about it later on our blog, so you can just go there and read all of the answers. Okay, I think that's all. So let's welcome Mariusz, who is going to be a host for us today and present the whole topic as best as possible.
Okay, hello everyone. So today's webinar is about serverless in Node.js, as Adam mentioned, and this is dedicated for those who aren't actually very familiar with serverless technology at all. But if you have some knowledge about serverless technology, then you might at least consolidate your knowledge, and I hope it will be helpful for you. I am Mariusz Richtscheid. I am working in TSH as a lead Node.js developer. On a daily basis, I'm participating in several projects, usually containing some technologies like microservices in Node.js, serverless technology. I'm also working as a front-end developer using React.js. If you'd like to contact me after the webinar, feel free to use links provided on the slide. So today I'd like to actually start with the very basic question: what does it actually mean to use serverless? Later then I'll try to answer the question: should we really use serverless in our case? Is it something that can give us some benefits, for example? Next, we will compare some most common cloud computing models because it's quite necessary to know the differences between them. Once we know them, we will choose a provider that will be hosting our application. And once we have chosen the provider, we'll choose the proper framework for it. We'll get use of that framework in creating a Hello World example. And later then, there will be much more complex example, actually with migration of our translation service we use in TSH called BABELSHEET. Okay, so there's a very basic question. Maybe it sounds very dumb, but actually the answer is pretty obvious. Of course, there are servers in serverless, but there is another perspective depending on if you are a provider or if you are actually a client using that technology. Because right now in serverless technique, we don't need to maintain, we don't need to take care of servers because everything is actually outsourced to vendor. He's responsible for that and we are paying him for this particular task. Moreover, with that whole management outsourced, there comes another thing, which is some features around it. And one very, very great feature is that actually most providers allow us to have dynamic scaling of their resources. So we, for example, we don't need to think of it, we don't need to take care of it. If we need more resources because our application grows, it's very big, then we can have all the necessary resources. And it's actually very good in case of some, let's say, spikes in traffic where you need much more resources in a very short period of time, then that dynamic scaling is actually effortless. One more thing about serverless is that in this technology, in this technique, actually, especially in functions as a service model, we only paying for what we are using. If our functions aren't being executed, so then we don't need to pay for that, even if they are still deployed and ready to process some incoming request. One more thing about serverless is that it really reduces some deployments when you are starting your project, because you don't need to take care of the whole infrastructure thing, and you can focus on your business code and logic. So you might be actually first on market and experiment with the software. And if you are first, then you can actually grab as many users as you want. And there's a very popular question if we really need DevOps team when we are using serverless technique, because, you know, once everything is outsourced, it might be actually an idea to get rid of them and use devs only. And it's an idea, but actually, even if a lot of it is outsourced, there are still a lot of things to do. We still need to monitor our application. We need to have proper strategies for deployments. We need to consider various other things like security, networking, debugging, scaling of the whole system, not only the functions. And this might get very complex. So our DevOps team is very appreciated. Okay, should we really use that serverless technology in our project? Actually, there is a very nice example of a readability platform. Once upon a time, it was a platform used for actually conversion of websites to formats that are readable by e-readers, of Kindle, for example. And before going serverless, they had their API with around 39 million requests per month, which gives around 15 per second. And it was actually a quite huge cost for them, because it was around 10 grand per month. And after going serverless, they changed their service name, but the cost was reduced greatly to around $370 per month. And it included also API gateway service, which was used together with Lambdas. So as you can see, we can actually achieve some very great cost savings, but actually that won't happen for everyone. It really depends on the business. It really depends on the kind of application we are creating. Because if there is an application with some which isn't working 100% of the time, which have some occasional requests and so on, it might be actually beneficial. But if we have some apps that are working 100% of the time, they are constantly processing something, then we would need actually to check if it's good for us, if it's worth switching to serverless. Of course, there are always some cons, even with the serverless technology. If you choose to use that, you need to be aware that you will be probably vendor locked, because for every kind of vendor, you have some different aspects of the infrastructure, some different configuration files, and it is very hard to migrate from one to another. Even if there are some frameworks that are kind of platform agnostic, it's still quite hard to achieve. One more thing is that for using that technology, you need to be aware that there are some changes needed for your application. You need to have it stateless with no long running processes. That might not be the case for everyone, but you still need to actually invest some time and to prepare your application to switch to serverless. There are various limits on execution time, on memory, and this is a very important thing to be aware of that. I will be actually presenting you some limits of AWS Lambda. And with such limits, actually it might not be possible to achieve every kind of solution we would like to implement. So we need to know them. There are various cloud computing models we can use nowadays. And the most commons are as follows. So first one is infrastructure as a service. And as you can see, there are multiple layers of that infrastructure. And in that particular case, we only manage some of them. In infrastructure as a service, we need to manage things like application, our data layer. We are going from runtime down to the operation system. And the provider actually is taking care of some other layers like networking, storage, servers, and so on. And if you'd like to use that model, you can actually use Amazon EC2 or Google Compute Engine. In next model, which is platform as a service, as you can see, there are actually less layers we need to take care of, and more responsibility actually goes to a provider. And there's an example of that using AWS Elastic Beanstalk, Heroku, or Google App Engine. And there is another model, which is function as a service. This is something we will be focusing on today. And as you can see, there's just one layer we need to take care of, which is application layer. So our only responsibility is code. And the rest of the layers actually they go to a provider. And there's an example of that. We can achieve that with AWS Lambda or Google Cloud Functions. And the last one, which is software as a service, as you can see, actually provider hosts everything, takes care of everything. And we can, for example, integrate with its software API or something like that. There's an example of that with Google Apps or Salesforce or Dropbox. And with such models, there is always hard to actually compare platform as a service to functions as a service. It's not very obvious what are the differences between them. So let's compare them. First main difference is that in platform as a service, we are actually running some software which can handle long-running processes, ends up all the time, and comparing to functions as a service, where we actually don't have long-running processes, each request is actually processed by a separate invocation of a function. And if we need some long-running processes, it's actually outsourced to some other services which take care of that. Another difference is that there's difference in scaling, because if we scale platforms, we are actually adding more and more processes, and we need to pay for all of them all the time. Comparing to functions, where we are executing just more functions concurrently. And yeah, we are just paying for the single executions of those functions. So depending on the size and type of our application, it might be actually beneficial for us to use functions. Okay, let's say we are interested in functions as a service. Then we need to actually choose a provider. And on the market, actually, there are a lot of providers right now. As you can see, we have many providers to choose from. And in TSH, we actually chose AWS because we used all of their other services in our projects. So it was quite an easy way to choose a provider which gives us a lot of integrated services. And their functions as a service option here is called Lambda. So let's look into it. Lambda actually provides a lot of different runtimes. We can use Go, .NET, Java, Ruby, Python, or Node.js, and Node.js in versions 10 or 12. And this is quite an interesting thing that there's a possibility to actually use some custom runtimes we can provide. It's very well documented on their website. And with Lambda, there comes pricing, which we need to be aware of. You can use 1 million of functions executions per month for free, which is quite a huge number. And then you need to pay just a fraction of $1 per 1 million requests thereafter. So it sounds like a cheap service right now. But you need to be also aware of another factor, which is gigabyte times seconds. You can use 400,000 gigabytes times seconds for free, and it means if your functions are using 1 gigabyte of memory, then you have like 400,000 seconds. But if you reduce that memory for your functions, for example, to half gigabyte, then you are allowed to run for free for 800,000 seconds, and so on and so on. So it's quite a good idea to observe your functions memory usage and lower if necessary. And there are also limits for AWS Lambdas. You can use up to 3 gigabytes of memory. And if your functions need more memory, actually, then it's wise actually to maybe change your approach, maybe divide some more complex computations into more functions, something like that. And you need to be also aware of that the maximum time duration of every function is only 15 minutes. So once again, if there are some tasks that are taking more than 15 minutes, you need to actually divide them. And another thing is that you can run by default up to 1,000 functions at the same time. It actually can be changed. That default value is very safe for users, but if you need more than 1,000, you can change that. You need to be aware of that. There is always some kind of a limit. You can just like run like 1 million concurrent executions, because even AWS won't be able to handle that for one particular user. So it's actually very good to verify if they can provide you the proper limitations. Okay, there is a question from Kacper. Is there a cold start when you use the function in Node.js? What if you want to use a lot of external dependencies? Yes, actually there are cold starts. I will be presenting that case later. If we want to use a lot of external dependencies, I don't exactly know what you mean. There is kind of AWS Lambda layers. So you can use some layers and load dependencies in those layers and reuse that in other Lambdas. So it might be actually beneficial to use layers if we have a lot of external dependencies. Okay, Surai is asking if is that 1,000 concurrent executions per Lambda? Actually, as far as I know, it's yeah, that's 1,000 per user per account, but I'm not sure right now. Actually, I guess there is actually also a limit per account, so you can just like have 1,000 functions with 1,000 executions each. You because that would kill their servers probably. So yeah, I think that was per account. But I encourage you to verify that actually. Camille is asking, is it really the cheapest available solution? As I said, it really depends. If you have a startup and you are creating some software, and let's say you have 10 users and they are making a few requests per day, then yeah, that's the cheapest, because your platform is available all the time. You pay just for some of the executions, and if you have used platform as a service for that, then you need to pay for all the time you run your application, like for the whole month, even if there is no traffic at all. Yeah. Okay, let's go further. Another limitation is actually deployment package size, which is 50 megabytes for zipped and 250 for unzipped deployment. And this is also important thing to remember, because even if you are making some Hello World application and you load a lot of Node modules into it, it might be quite a lot if you prepare that deployment package size. Yeah, and right now, once we have chosen our provider, let's choose the proper framework. Some people might ask, why do we even need framework at all? Actually, there are a lot of pros of having a framework. One, which is very obvious, is that it actually automates a lot of things for us. We don't need to use AWS console nor CLI. We don't need to type a lot of various commands. That framework actually can do it for us with some more comfy commands. They usually have some abstraction on those commands, so we can just like run serverless deploy and it does all the stuff. Frameworks are usually translating some simple configuration files into more complex ones, like for CloudFormation, which is usually used under the hood in AWS. CloudFormation is actually their service responsible for provisioning the whole infrastructure, and they have like very complex configuration files. We don't need to know all the details of those files because you have a framework for that. And frameworks are usually pluggable. There are a lot of various plugins. Like in our case, we are using TypeScript, and you need to deploy your functions in JavaScript. So we have a plugin for that, which actually transpiles TypeScript to JavaScript before deployment. And there are two very popular choices on the market. There are more options, but I'd like to compare two of them. First of one, which is serverless framework, and second one, which is AWS serverless application model called SAM. And with serverless framework, we actually having a framework that in theory is platform agnostic. And I say in theory because a lot of configuration you need to provide is actually AWS specific, and if you are using it for AWS, and there are cases you actually need to know some details of the infrastructure you are using under the hood. But there is actually an advantage to serverless framework. You can use it with many different platforms. And in SAM, it's just for AWS. That's their tool, and you can't use any other platforms with that. With serverless framework, there are a lot of more deployment options. We can use it for many providers, as I said, but we can actually make some things like deploy stuff, rollback, and so on with less commands, because it's doing many more things under the hood. Comparing to SAM, which has some less deployment options, You need to actually know more the low-level details of it to make it running. And with serverless framework, actually, it has quite worse infrastructure emulation. You know, it supports multiple providers. So if you'd like to emulate something locally, you need to find a plugin for that. And it's worse because, you know, it's just a plugin with some local emulation without the whole infrastructure. And the SAM has better infrastructure emulation because in this case, it even uses a Docker image, which emulates some of the AWS services like Gateway, Lambda API. You can even use some fake events. So you are more sure if your whole solution works correctly before deployment with SAM if you are using it for AWS. But today we'll actually choose serverless framework because it's much easier to start with, and it's very good choice if you'd like to start experimentation with it and make some first applications. So let's start with the framework of our choice and use it to write a hello world example, like for every language and for every technology we choose. So to start with serverless, and we just need to provide two files at start. First file is actually our function and a handler for that function. As you can see in this particular example, we are just exporting proper function which returns an object with some body, and that function has very interesting arguments. First of the argument is an event which has some input data, and here we can obtain data from some other services. Like if our function is being executed by an event actually caused by other service like S3 when the file is uploaded, then we can have some information about uploaded file in that event variable. And the next is context, having some information about remaining time, request ID, function name, and so on and so on. It might be useful, but not all the time. And once we have that very simple function handler, we need to provide a proper provisioning config, which is serverless YAML in this example. And as you can see, we are just defining the name of the service, some details of the provider. In this case, it's AWS and Node.js 12. And the most important section here is functions section, where we define our API handler and attached HTTP event to that. And with such config, we actually are able to create the whole infrastructure, having our function and API gateway, which will be connected, linked to our function, and which will be processing the whole traffic. And as I said about events, they can come from various sources. It can be S3 or DynamoDB, some notification services, email services, and so on. And once we are ready with our code, we can actually install serverless NPM package. And once it's installed, we need to actually authenticate with AWS using their CLI. It won't be covered on this slide, but it's needed to do that. And once we are ready, we just need to trigger a deploy. There will be a lot of output in our console. Once it's ready, you can see some details of the whole operation, and there's a section with available functions, their names, available endpoints, and addresses for those endpoints. And we can check if that endpoint is working correctly just by sending a request. As you can see, we have our hello world returned. And as there was a question about cold starts, I will just now try to answer you what has just actually happened under the hood. So during first invocation of a function, actually our provider needed to create a kind of container. In AWS, it's called micro virtual machine, having our runtime and our function. And yeah, it takes time to actually start that virtual machine, and it's called cold start. And after it started and after it has processed our code, we get a result. But later then, if we execute our function more times, that micro virtual machine is actually up and running, and it will result in having our result faster, because you know, our provider does not need to run that virtual machine once again. But if we actually don't send any more requests for a longer time, those micro virtual machines might get deleted as well, and then we'll actually be having another cold starts later. It's very wise to, if your application is very, you know, you can't have like cold starts in your system. You can keep those functions warm by scheduling execution of them like for every 10 minutes. You of course need to pay for those invocations, but at least you will have them warm and with no cold starts. And there's one more important thing, that between those executions, if it's still the same container, you have access to cache memory. So you can have some computations, some complex computations being made in one invocation. You can cache them and reuse them in another function, but you always need to check if there's actually anything in that cache, because that cache is ephemeral. It might get removed as well. But having that actually included in your code, yeah, it actually might help you having faster times and, you know, lower costs. Okay, so that was quite an easy example of Hello World application. Now I will try to actually migrate our translation service called BABELSHEET to Serverless. So as I said, it is a translations management system. It under the hood, it actually uses Google Spreadsheet, and they have a very good user interface where you can work with multiple users, which can edit those translations at the same time. And it also gives you a lot of other possibilities, like you can have automated translations to other languages. They have that API included in Google Spreadsheet. And with BABELSHEET, we can generate translations in various formats through CLI tool or through a web server. And you can actually check that library at our GitHub page at the link provided on the screen. And before going serverless, we had a diagram like this. It consists of two Node.js processes. First process is called a producer. It actually has built-in scheduler, which schedules an operation to obtain Google Spreadsheet and process that, generate proper cache translations, and store them in Redis, which is our cache storage here. And another process, which is API, based on Express.js, which is actually giving us the translations we need if we just send a proper request. and it's using our cache translations as well. And we just now need to change that to the functions as a service model. And now we have like two lambdas. First lambda is our producer, and as you can see, it doesn't have a built-in scheduler like now, because this kind of responsibility of the application is now outsourced to the outer external service. In this case, it's called CloudWatch Scheduler. It's one of the AWS services. But the main logic is the same. If it's scheduled, it fetches Google spreadsheet, translates it, and stores in a cache. In this case, it's DynamoDB storage, because it was quite easier to prepare that provision, that whole stack, DynamoDB instead of Redis, but there could be Redis too. And another function, which is API. As you can see, it doesn't have any web server in it because it's called by API gateway. It's another AWS service, but the main logic is the same. It's processing request and sending proper result to API gateway, which is later then sent back to us. Okay, so let's actually try to migrate that up to serverless. So first things are very important to do. If you have a stateful application, you need to actually get rid of state, and because you need to have it now stateless. Fortunately, we had that our application stateless, so that wasn't the case. But you also need to get rid of long-running processes. As you could see, we just got rid of those processes just by outsourcing them to some other services. But there are even more steps that are quite helpful to migrate to FaaS. First of all, it's quite wise to use environmental variables to provide some configuration. It makes it much easier to work locally on it than on some staging or testing environments, and then we can just provide some secure keys to your application on production. If you have a possibility to do that, just make a storage abstraction, and because later then, if you need to change storage from like Redis to DynamoDB in our example, if you have proper abstraction with same interfaces, you can just inject your proper storage implementation to dependency injection container, and it should be working just like that. Of course, it's not always possible. Our case was quite simple. We just had some key value storage. There were no any other more complex queries there. Then we just need to write proper function handlers for our application. And last but not least, we need to prepare our stack provisioning. Okay, so let's take a look into our code. Let's start with API. So before going serverless, it had an entry point which was looking like this. It's just a small code snippet to make it more clear and more visible right now. So we had that our entry point where we were injecting our storage to a proper dependency injection container, where we then were just getting the server, the application from our container, and we're listening to a proper port. And that actually was starting our server, and it was listening for incoming requests. And there are key lines here that will get changed, because right now, after going serverless, we are just now using another kind of storage. It was as simple as, of course, implementing that storage, but in our handler, it was just injecting another kind of storage. And right now, we are still resolving our application, but comparing to the previous slide, we aren't actually starting our Express.js web server. We are not listening to a port. We are not getting any incoming requests there. We are just exporting proper functional handler here. And for Express.js based applications, it's quite easy to start with because there is a serverless HTTP package on NPM, which can wrap your entire Express.js based app into one handler, which can be then just used as a whole. So it's a quite nice way to start with, just by exporting it like that. So our API function is ready. Now let's go to our producer. And here's the main logic of our producer. And that logic won't get changed actually before and after serverless. So it just fetches some spreadsheets from proper API, then it transforms them, and at the end it stores them in proper storage. And before going serverless, we had we were importing our scheduler. It was invoking our main function with a configured scheduling time. It's like you can see, it's a cron-like configuration, and it was actually running in a long-running process. And after going serverless, as you might guess, we needed to get rid of long-running processes. So there is no scheduler at all, but in a handler we needed to write, we are just using the same main function with the same logic as previously, but it's now wrapped in some error handling and proper message sending. And right now, if we have our function handlers, we need to actually write a proper provisioning for the whole stack. And as you can see, it's not platform agnostic at all. It's a configuration for serverless framework, but there are a lot of details about AWS stuff. Like you can see some Amazon resource names included, some roles configuration for proper roles, and it might be complex at start, but fortunately there are a lot of examples, and you can just visit serverless framework documentation. They're very handy example of how to use it. And in this config, we are here we are actually using a TypeScript plugin for our application. And as I said, we needed to define proper role statements to actually make our functions executable in a secure manner. So once we have details of our provider, we need to pass a configuration for our functions. And you can see for API, it looks very similar to our Hello World example, but there's another function which is producer. And in this case, we are doing some more things, like we are passing some environmental variables there, and they are not hard-coded right here, because that's unsecured to actually hard-code any passwords in your code. They are coming from AWS Systems Manager Parameter Store. You can store those every kind of some API keys and so on securely there, and then just use it here like that. Those configs will be passed to your functions after they get deployed. And there's another event we are defining here. So instead of HTTP, we are using a schedule event here. And as you can see, with just as simple configuration as that, with defining rate of 5 minutes, it actually creates the whole CloudWatch scheduler under the hood, and it's linking it with our function. And there's a last section for that configuration file, which is resources, where we define our DynamoDB table and all the necessary properties for it. And it's also, just like previously, it's quite an AWS thing here. So just grab some documentation and it will be helpful to prepare that provisioning config. And after our application gets deployed, you can see that on AWS console preview that everything is up and running, and it is actually looking very similar to what we had on our diagram with all the proper services linked together. Okay, right now, because our producer doesn't have an external API, so there's no way to invoke it externally, but we can just use a CLI command, which is serverless invoke, but we need to, of course, be authenticated with AWS to do that. And here we can invoke our producer to actually grab translations, transform them, and store in cache. And once our producer is done with that, we can actually make a request for our translations through our API gateway. And as you can see, there are some translations returned. There are even more commands we can execute with that serverless CLI tool. We can, for example, execute logs command and choose a specific function. And in those logs, we'll have all the necessary information we are logging and AWS is logging regarding our function. Another quite handy command, which is metrics, where we can see like how many invocations were successful, how many errors we had, average time of a function. And in these logs, there is a very interesting thing, because as you can see, we were built for 200 milliseconds and our function was running for around 115 milliseconds. And yeah, that's the case. We are actually getting billed for every 100 of milliseconds we use. So actually there's that remaining time in our function context, so we can actually check and measure how much time we have left, and for example we can reuse that function to mine bitcoins or something like that, just not to waste the time that we have for our functions. Okay, and once our function is serverless, once our application is serverless right now, we still have some room for optimizations. We can, for example, add an HTTP cache on our API gateway, and with that cache, of course, it really depends on your case, but if you have some functions that should return the same result for the same arguments, then if it's cached in API gateway, we don't actually need to invoke those functions. We can save costs, can reduce the time for the response, but we still need to actually pay for another API gateway service. Another case for optimization is that we can actually lower memory which is used by our functions. It's configured by default that it's using 1 gigabyte of memory, as I remember correctly. And for most of the cases, we don't need that much memory. We can lower that. We'll have more time to execute our functions. It's quite wise to use execution context. That's that ephemeral memory cache that I was mentioning on one slide. And when you use that, you can actually save a lot of time if you have some more complex computations. And last but not least, if you are using some external services, just make sure they are quite fast, because if you wait for something external, you just pay for that time. So for example, if you need to use some cache memory, you can use Redis, which is quite fast. Okay, so now we have the whole application being serverless. So let's make a short summary of what we've learned. So first of all, you really need to calculate. You really need to check if it really is a solution for you, because this is not always the cheapest solution, depending on the type of the project, type of the solution you are developing. You need to be aware of a lot of limitations of it, that the functions must be stateless, there are no long-running processes, and it's very, very important to remember that. Then if you really like to go with serverless, then just choose proper provider and framework. And it's actually a good idea to compare some of them before using them in a project, because there are a lot of options and their pricing models are quite different, and it might be actually cheaper to use one provider comparing to another provider. And once you're ready with provider and framework, just prepare your app for going serverless. So make sure it's stateless, no running processes, it has proper storage abstraction, you have some environmental variables injected into it, so it's very easy to actually run it on your infrastructure. And then write function handlers, of course, prepare proper provisioning config depending on which kind of framework you used. And at the end, just deploy your application, try to optimize it, and of course, repeat the whole process to make even more cost savings. And there are quite a few things worth knowing. If you are really interested in functions, there is a service called AWS Step Functions, which can give you a possibility to run multiple functions together in a kind of a workflow where you can define some more complex business processes, and some functions might get executed depending on the result of previous executions of other functions. So it might be really helpful for some big apps. Next one is Lambda layers. As I mentioned, you can reuse your code across multiple functions. You don't need to deploy some common packages you are using in your project into every Lambda, because those layers can actually help you with that. With Lambdas, you are able to actually prepare some zero downtime deployments called blue-green deployments. You can have like a function with multiple versions of it at the same time deployed and processing requests, and you can then just switch to a newer version if you know that the previous functions aren't being executed and there are no more users using them. With serverless, with Lambdas, it is possible to actually prepare some GraphQL endpoints. It's a very nice case to use it for GraphQL. And last thing, which is Google Cloud Run, it's a solution from Google, also for serverless technology. And comparing to AWS Lambdas, you can actually run your existing applications using their platform, and you don't need to actually prepare and provide proper function handlers, and you are still getting billed for only executions. So it's a very nice alternative. I haven't been using that, but it's actually worth checking. It might be very interesting. And this is actually everything today. And we've got that survey about the state of microservices. We would like to actually ask you to visit our website and use our survey to provide us some input data. Then we'll be able to actually create a report of the current state of microservices in the current year, and we'll get back to you with that report. So we'll have some information about how we are using microservices, what kind of languages we are using, what kind of tooling, and so on and so on. Moreover, we are preparing a newsletter in which you can get very interesting links to some technologies, to some other articles we think are very interesting, and it's very handy for both devs and tech leaders. So if you're really interested in some news about IT stuff, then feel free to sign up into our newsletter. And this is actually everything for today. Thank you for attending my webinar, and see you on the next one.